Hello, and thank you for joining today's webinar on transforming regular LSR into self-bonding LSR. My name is John Wolf, and I'm joined today with our presenters, Katie Tuttle and Paul Wheeler. Before we get started, just a few housekeeping items. While Katie and Paul are speaking, if you have any questions, please submit those to the Q&A box, and we'll answer those at the end. We're also live tweeting today's webinar and welcome you to join on the conversation using hashtag Chemlok3Stream. In case you experience any issues with audio, we are recording today's webinar and we'll be sending a link to view after. Finally, we have a short survey following today's webinar for you to provide feedback. With that being said, Katie and Paul, I'll turn it over to you.
Thank you, Jonathan, for the introduction. I'm Katie Tuttle, and first I would like to say good afternoon and good evening, as I see we have people from around the globe on the line with us today. So thanks everyone for joining. As a quick note, before starting today's webinar, we will be live tweeting our webinar today, so please join the conversation by following us on Twitter at Lord Corporation. For today's webinar, I'll review what Chemlok3Stream is, how to use it, as well as the benefits to using this patent-pending technology over self-bonding LSRs or traditional primer or adhesive systems. Paul will then cover in more detail how to incorporate Chemlok3Stream into your existing injection molding process and a benchmarking study of how Chemlok3Stream bonding performance compares to self-bonding LSRs. As John mentioned at the end of our presentation today, we will have a Q&A session, so please do submit your questions throughout our presentation. To start things off, I wanted to briefly give some background on Parker Lord. We've been delivering the best-in-class rubber-to-substrate bonding solutions for over 90 years, with a focus on solving our customers' most challenging applications. With our extensive bonding expertise and passion for problem solving, we've developed a new innovative way for bonding LSR to various substrates, which we'll talk more about today. What is Chemlok3Stream? Chemlok3Stream is an LSR adhesion promoting additive that converts regular LSR into self-bonding LSR. Our Chemlok3Stream adhesion additive is designed for dosing via a third stream pump into your injection molding process. You can use standard dosing equipment to feed Chemlok3Stream, very similar to feeding colorants into your injection molding process. To achieve excellent bonding performance, we recommend dosing Chemlok3Stream at 1 weight percent to LSR. This patent-pending technology is the most cost-effective solution for bonding LSRs. Raw material cost savings is just one of the many benefits to using this technology. In addition, the advantage of using Chemlok3Stream impacts all aspects of your business, including optimizing manufacturing processes, reducing capital investment costs, and expanding your supply chain while maintaining excellent performance and quality. So let's explore these advantages in more detail. Chemlok3Stream can be used with regular LSRs, which are more readily available and more commoditized than self-bonding LSRs. By eliminating the need for expensive self-bonding LSRs, you could save up to 50% in raw material cost alone. Now let's walk through a quick example to demonstrate this cost savings. In the chart on the right is a hypothetical part manufactured in an injection molding process. The column on the left is the manufacturing cost using self-bonding LSR, while the column on the right is the manufacturing cost using Chemlok3Stream at 1 weight percent with regular LSR. Since the manufacturing process does not change, the labor and machine costs are the same for both scenarios. Paul will explain later how Chemlok3Stream can be easily incorporated into an existing LSR manufacturing process. In yellow, you can see the raw material cost savings is driven by the switch from expensive self-bonding LSR to regular LSRs with Chemlok3Stream. Also, using Chemlok3Stream has multiple advantages in the manufacturing process. If you are using a traditional primer or an adhesive system, you can eliminate the labor and challenges associated with the application of this type of bonding method. Many traditional primer or adhesive systems contain or are diluted with harsh solvents that present manufacturing hazards. By using Chemlok3Stream, you can remove the volatile organic compounds associated with these harsh solvents from your manufacturing facility. In addition, Chemlok3Stream increases your design flexibility as this one formulation is capable of bonding multiple substrates across a wide range of durometers. Another great advantage of using Chemlok3Stream is the fact that you can use standard off-the-shelf dosing equipment and no specialized tooling or mold coating is required, therefore minimizing your capital costs in comparison to some self-bonding LSR solutions on the market today. By using Camlock 3-Stream, you can improve your supply chain in several areas. The first area is in lead times. Self-bonding LSRs typically have significantly longer lead times than standard LSRs. By using Camlock 3-Stream with regular LSRs, you can reduce your lead time, which in turn allows you to optimize your raw material inventory. Again, since Camlock 3-Stream is used with regular LSRs, which are more readily available across many suppliers, you can expand your supplier base and improve the flexibility across your supply chain. With all of those advantages, you also get proven performance and quality every time. We've done extensive performance testing over the past several years and validated that Camlock 3-Stream works with multiple plastics and clean metals across a wide range of durometers from 30 up to 75 short A. Some plastic substrates include PBT, nylons, PPS, and PPA. As we expand this technology, the list of substrates and durometers continues to grow. At this time, we are now going to launch our first poll question. If you would please let us know what substrates you most commonly use in your current manufacturing processes. And you can check as many that apply to you. So thanks for your feedback. I'll now turn it over to Paul to go into more detail regarding the bonding performance of Camlock 3-Stream.
Thank you, Katie. So let's talk about some of the performance results with Camlock 3S902, and this is the commercial name of our very first product in this product line. All right, so the first thing I want to talk about is ease of use of this product. It's very easy to use with off-the-shelf equipment. As Katie mentioned, it's a liquid, it's a low viscosity liquid. It's pumped in the same way that you would pump in a colorant or other additive. It gets injected into the stream just prior to the static mixer. In terms of injection molding parameters, there's nothing too outside of the norm. So when you think about injection speeds, pressures, gate location, there's really no change that needs to be done there. Temperature and cure time do have an effect on the adhesion, and those can be used to optimize the adhesion. So with hotter temperatures and longer cure time, you will get better adhesion. And there is a temperature requirement for this material, so we recommend that it's molded at 125 degrees C or higher, which that will encompass nearly every LSR. Okay, next I'd like to talk about a benchmarking study that we did. Now I don't have time to get into a huge amount of detail. I can only give a high-level overview of this study, but what I encourage you to do is to go to the website. We have a white paper that we just published, and there's lots and lots of technical detail in that white paper. So if you're curious, I encourage you to go there and check that out. So what we wanted to do here was take our Camlock 3-Stream and compare it to competitive self-adhesive grades that are on the market today. So in this study, we took three silicone systems. The first one was a 40 durometer standard non-self-bonding LSR, and we added 1% of the Camlock 3S902 to that to convert it to self-bonding. And then we compared that to two competitive products from different global manufacturers of LSR. We picked a 50 durometer grade and a 40 durometer grade. In terms of the plastic substrates that we tested it with, we used three plastics: PBT, which is polybutylene terephthalate, PA6, also known as nylon 6, and PA66, also known as nylon 66. After molding, the parts were post-baked at 150 degrees C for 1 hour after molding. At this time, we're going to launch our second poll question, which is, what durometer of LSR do you most commonly use? Thank you for those responses. Let's continue on, and I will show you the test results of our study. So when we mold parts, the first thing we check is peel strength. Now, before I go over the peel strength data, what I'd like to do is review the geometry of the test specimen. So that's shown in the upper left corner of the screen. The blue color is the LSR, the tan color is the plastic substrate. So you can see it's basically a dog bone type specimen that is injected across the face of the plastic coupon. And with this geometry, it allows us to do a 90-degree peel test, which is how we normally test these types of materials. So next, I'm going to show you the peel strength results. So before I put the data up, let's go over the chart. So the vertical axis is peel strength, and that's given in newtons per millimeter. The x-axis is the type of plastic. So when we look at the blue bar, which is the regular LSR plus 3-stream, you can see we're pretty stable across the 3 different grades of plastics. Our peel strength was just above 6 newtons per millimeter, which is actually quite strong. In this case, the rubber was actually failing, so this more or less measured the strength of the rubber in this case. And I'm going to talk about failure mode on the next slide so you can get a better feel for what that looks like. When we look at that compared to competitor A, what you see is that the 3-stream system performed better on PBT. On PA6 and PA66, you can see we were a little bit less, but I will point out the competitor A is a 50 durometer silicone versus the regular silicone that we used was 40 durometer with 3-stream. So the higher value is actually due to just the stronger silicone that we use for competitor A. When you compare it to competitor B, you can see that we've exceeded the performance in all cases. So the bottom line is Camlock 3-stream gives excellent adhesion on these 3 plastics. Let's talk about failure mode. So we just talked about peel strength. After we peel the parts, what we do is we take the part and we look at it and we determine where did the failure happen. And there's 3 potential failure modes. There's cohesive, boundary layer, and adhesive. Cohesive failure means that the rubber failed. This is what we like to see. That means the adhesive strength is greater than the strength of the rubber. Boundary layer is something in between cohesive and adhesive, and that means you might have like a very thin rubbery residue left on the coupon, but it's not quite cohesive failure. And adhesive failure means a clean peel, so you're not left with any residue on the plastic and the silicone cleanly peels off the substrate. So let's first look at cohesive failure. So you can see in the example of PBT, the 3-stream modified system significantly outperformed both competitor A and competitor B, and you can see that by the much higher cohesive failure. On the nylon 6, everything is about the same. Everything performed reasonably well on nylon 6. On PA66, you can see that the 3-stream system outperformed competitor A a little bit, and then greatly outperformed competitor B. And when we start filling in the rest of the failure mode picture, next we'll add boundary layer failure, and the story doesn't change a whole lot, but you can still see, like on the PBT, the performance is much better with the regular LSR and 3-stream system. Nylon 6, everything's pretty equivalent, I would say. And the nylon 6.6, the regular LSR was about the same as competitor A, but much better than competitor B. And then the balance is adhesive failure. So you can see quite a bit of adhesive failure on a lot of the competitive products, but the 3-stream system had almost no adhesive failure in the entire test. Bottom line is Camlock 3-stream achieves very strong rubber tearing bonds. So let's talk about curing performance. Whenever we mention putting additives into silicone, people are rightly concerned about, does it affect the curing performance and does it affect the mechanical properties? So we're going to address those 2 concerns right now. So the way we look at curing performance is with an MDR curing curve. MDR stands for moving diameter. And in this test, it's performed at 160 degrees C in a rheometer. You're basically watching the rubber become stiffer as it cures. So the vertical axis is torque, and then the horizontal axis is time. When we look at the curve for regular LSR, that's a standard normal looking cure curve. You can see it's more or less cured in about 30 seconds. When we add 1% 3-stream to the regular LSR, you can see the cure curve shifts a little bit to the right, so it does slow it down modestly, maybe by a few seconds. However, when we compare it to competitor A, what you see is that competitor A is significantly slower in curing than either the regular LSR or the one that's modified with 3-stream. So that shows that we cured a lot faster in that instance. Now compared to competitor B, it's got about the same cure speed as the regular LSR. But the bottom line is that the 3-stream modified system, it maintains that curing range within a normal range for LSR. Let's talk about physical properties of the silicone. So in this test, we took 2 different grades of LSR, just regular non-self-bonding LSR from 2 global suppliers. and added 1% 3-stream, and then looked at several different properties: hardness, tensile strength, elongation, modulus, tear strength, and compression set. And you could see in some cases you saw increases in properties, in some cases maybe a little bit of a decrease. It depends on the grade, etc. But the bottom line is that there really is not much of a change in the properties of the silicone. I wanted to point out to you that we're here to engineer your success. We have a fully equipped application engineering team to support customer trials, to assist with troubleshooting and process optimization. The whole point is to work with our customers to help you guys be successful and successfully use our products. And we also have significant testing capabilities at our R&D facility in Erie, Pennsylvania, which is where I'm based. We have plastic and LSR injection molding machines. We can do all kinds of work for you, whether it's testing out your silicone, your substrate, verifying the performance, helping you figure out how to make this work for you. And we love working with customers, and we welcome that. With that, I will turn it back over to Katie to wrap us up.
Thanks, Paul. Excellent overview of our technologies. To summarize today's webinar, Camlock 3-stream can convert regular LSR into self-bonding LSR, and it bonds a variety of plastic substrates across a wide range of durometers. And the big key advantage to Camlock 3-stream is the raw material cost savings associated with eliminating expensive self-bonding LSRs, as well as eliminating traditional primer and adhesive applications, improving your overall manufacturing efficiency. I'd like to thank you all for joining our webinar today. If you would like more information, please visit us at lord.com or feel free to give us a call at the number provided. We'll now transition into the Q&A portion of our webinar.
Thank you, Katie, Paul, for the presentation today. Just a reminder to submit any questions that you have to the Q&A chat box. Katie and Paul, our first question we received, and Paul, this is a question for you. All the data presented was with a post-bake. Is that required?
Great question. So it's not necessarily required. It really depends on the requirement of your part. So in many cases, the adhesion that you get without a post-bake is sufficient. In some instances where you just need to hold a gasket in place or something like that, if you need very, very strong adhesion, rubber tearing bonds, typically you would need to post-bake.
Thanks, Paul. And then Paul, our second question that I have, how will I not bond my mold shut?
Another great question, and we get this often. So when we talk about bonding to metals, we do have the ability to bond to clean metal, and that scares people when they hear that because they think it's going to bond to the mold. But I want to point out that the mold is not clean metal. LSR has built-in mold release, and it seasons the mold as you run it. So that's why a 3-stream will not bond to a seasoned mold. Now, if you're starting a fresh mold, we do recommend that you start off with mold release and then run a few cycles, and typically that's enough to get you started.
Thanks, Paul. And Paul, our next question that we just received, what other substrates have you tested, and do they work with polycarbonate?
So we've looked at, I think Katie mentioned a few of the other plastics, such as PPS, PPA, other types of polyamides. It works well with that, like nylon 11, nylon 12, different kinds of clean metals, aluminum, steel, zinc. With polycarbonate, it's a little bit more of a complicated story. What we found so far is that with plasma treatment, it bonds really, really well to polycarbonate. And we're looking at other ways, whether other surface treatments may work with polycarbonate, something we're taking a look at.
Yeah, and I'd like to chime in there too, that if we have not tested a plastic that you are interested in, or you have an application that maybe we haven't discussed today, your exact substrate, feel free to reach out directly to us, and we can discuss that application and take a deeper dive into whether or not Camlock 3-stream is a good fit.
Great. Thanks, Katie and Paul, for that. Paul, our next question, how many silicon suppliers and actual durometers have you tested a 3-stream with?
It's quite a wide range. We've looked at every major supplier, every major LSR supplier. We've at least evaluated some of their silicones. It works with most of them. We've worked with durometers ranging from 30 up to 75. And sort of tailing on to what Katie just said, if there's something outside of that range or a specific grade you'd like us to look at, we're happy to take a look at that for you.
Paul, the next question that we received from the audience, can I mix the additive with my colorant instead of streaming in separately?
So we don't recommend that you mix the colorant with the 3-stream. Typically, they're not miscible, so we don't expect them to mix together very well. And we do recommend that you inject them through separate pumping systems.
Thanks, Paul. Our next question that I have for you, will this work with low temperature cure LSR?
Interesting question. So we're actually, the current system needs some kind of temperature to get the bonding to function. So it's not really designed for low temperature systems. However, I'll mention that we're still developing new products here, and we are in the process of getting pretty close to being finalized of a new product that would potentially work with low temperature systems. So stay tuned for that.
And then Katie, question that I have for you from the audience, do you have medical testing complete?
Yeah, so this is another question we get often, just given the fact that LSR is used heavily in the medical industry. So right now, we are currently completing the ISO 10993-5 and -10 testing, so the biocompatibility and the skin irritation testing. We should have the results shortly, and once that data is available, we will share that on our product data sheet, so keep an eye out for that, more online. So there's more to come there.
Thanks, Katie, for that. Our next question, specific to the region, question that we have is, are these region products available? And if so, how can I get a sample?
Yeah, so I can take that one. Our current product launch is focused on North America and Europe. However, if you're outside those two regions, we can still work with you directly to get samples and discuss specifically your application. As for samples, we do have production samples available, so please reach out via lord.com or through the 1-800 number or 1877 number that was provided earlier, and we can directly work with you to get a sample. And John, if you could go back maybe to that contact slide so we can show our contact information. Yeah, perfect, thank you. And we can discuss your application more. We encourage you to reach out. We do have either distribution networks set up where you could get a sample, or you can reach out directly to us.
Thanks, Katie. The next question that we received from the audience, does Parker Lord also sell LSR?
So no, we actually only manufacture the adhesion promoting additive, so we only make the Camlock 3-stream. We do have a distribution network set up, as I mentioned earlier, where you can purchase both Camlock 3-stream as well as potentially standard LSR. So depending on where you're located in different regions, we can direct you to those distributors or directly to us. But really, at the end of the day, you're open to choosing your preferred LSR supplier, so it's up to you at this point.
Thanks, Katie. And Paul, our next question for you, can I add more or less than 1 weight % of this additive?
Absolutely. Yeah, that's one of the nice characteristics of this product, is that you can vary the percent to get the performance that you need. In fact, we've had a couple of trials where we found that 0.5% was the optimum loading level. So yeah, if you need more adhesion, you can put a little bit more in. Sometimes you don't need quite as much. It's very tunable by the customer.
And then just a follow-up to that, Paul, can I add 3-stream to the base LSR instead of 3rd streaming?
So in theory, you could. That would take special mixing equipment that most molders don't have. It's not something that we've done much evaluation in. Theoretically, it should be possible.
Thanks, Paul. And then our final question from today, Paul, this is for you. Is this an aqueous product?
No. So there's no solvents, there's no water. It's 100% solids. There's no volatiles to deal with, whether it's water or solvent.
That's all the time that we have today. If we didn't get to your questions, Paul or Katie will be in touch for follow-up. Katie and Paul, thank you again for today's presentation on transforming regular LSR into self-bonding LSR. Thank you everyone for joining today's presentation.